Hey everyone, welcome to our talk today. Rinaldi's coming up to talk about creating an interactive AI Twitch streamer on AWS. So come on up, Rinaldi. Thank you.
How's everyone doing today? Good, good. Great to hear. Are you all ready to take a bit of a look into how AI is currently being used within Twitch streaming? Great. So I'm Rinaldi, and I'm going to be talking about creating an interactive AI Twitch streamer on AWS. So I'm also currently a community builder, and we're going to get straight into it. So what's the agenda going to look like? So pretty much we're just going to cover 5 main items. So firstly, I'm going to be introducing a bit on why we do AI streaming. Second, we're going to go into the architecture. Third, we're going to be looking into the implementation towards creating this kind of solution. Fourth, we're going to be looking at a bit of a demo of how that would look like. And finally, we're going to be looking at what the future of streaming would look like with these kinds of solutions in place. So why do AI streaming in the first place? As streamers often want to look at different ways of generating content, creating new experiences for viewers. So one of the ways that I thought about this for a while is that what if we actually tried a different experience? With the rise of generative AI, it has opened a lot of potential for us after all. So what I wanted to really create was a unique and interactive experience to engage with viewers. And that was something that was able to be done, particularly with generative AI. And what if we can actually create a streaming service that could pretty much run online around the clock to inform users 24/7? So maybe not necessarily for entertainment, maybe also for informational uses, for example, for organization. So there's a lot of potential use cases that you can see from this kind of entertainment being put on. And it's definitely customizable as well based on your own use cases. Aside from that, of course, in general, it's just being able to have fun as well in the process too, because that's all what Twitch streaming is all about, right? Being able to have fun with what you're doing, understanding a bit on what you can do with it. So yeah, with the rise of generative AI, it's pretty much all about being able to see what use cases you can get out of it and just have fun in the process. So what does the architecture look like for this kind of Twitch stream? Well, firstly, we have users interacting from Twitch. So you would normally be streaming from Twitch, and users would be viewing you from Twitch. But then we can then go into Amazon EC2. Now, I just want to make a quick caveat that you can also do this locally too. So for example, for my local setup as well, I also run it on my own local laptop. But EC2 is an alternative that I experimented with as well that also runs properly fine too, provided that you provide it with the right EC2 instance that is able to support the streaming of workloads. Because as you know, streaming workloads are very compute intensive and require specific instances for that. And we'll talk about that in a bit too. After that, it communicates through the API gateway to be able to communicate with Lambda functions appropriately. So as you can see, we're starting to get more into the communication part of things when we start to communicate with Bedrock and Secrets Manager. So we go into Secrets Manager because we want to be able to fetch the secrets that we need, particularly in regards to, for example, fetching the necessary API keys relevant to Twitch. So Twitch itself has an API key that we will need to fetch as part of this integration, and of course, those relevant to Bedrock as well. So we fetch that, and with Bedrock, we make a few calls. And so it's going to be very event-driven, and we're going to be exploring that in a bit too. So every time someone sends a Twitch message, the streamer will respond to them based on that message. And so it'll be a very event-driven architecture. After that, we then go into DynamoDB. So the Lambda function that goes to Bedrock also stores the context within DynamoDB too, so that the streamer can also train based on the data that has been done and obtain data to continuously learn from what it has done before. Afterwards, we also then do a bit of a text-to-speech with Amazon Polly, so we get it out, particularly in terms of its text, and we want to be able to have the AI streamer then voice what is currently being communicated with Bedrock. So essentially, we're feeding in the data that we have obtained from the text from the users, then we feed it into appropriately into Amazon Poly so that it's able to output the data. So now let's start getting in a bit of the coding segment. So let's start first into how we can capture messages of the events over Twitch. So we can see over here that we're declaring a class as the bot. So just a bit of an introduction to this as well. We're going to be coding this in Python. This is currently what's implemented in. And what we do is that we start off by creating a conversation in the form of a list so that we're able to store the history of our conversations. And we appropriately also initialize the conversations as well. So basically, we're putting through our appropriate token for Twitch, and we also put through the initial channel as well, which is, in this case scenario, my channel is called Himinerar. And after that, we do a bit of LangChain. So pretty much we just put through add user message and add AI message to be able to then feed it to context. And we then start to initialize our event architecture. So we're initializing the event message. So every time a user sends a message, it'll be retrieved and it'll be saved as a response. So we want to be able to predict what the response is based on that particular message. So that's essentially what this particular code is doing at a high level. And on the Bedrock side, we then start into looking into how we can use LangChain. So you can see that we're using conversational buffer memory to store context. We are initializing our Bedrock model. So in this case scenario, I'm initializing it using the Titan model. So as part of this as well, I'm putting through 1,000 tokens, putting through a temperature of and top P of 0.9, which is appropriate given that we want it to be a bit whimsical and not really based on facts, because we want it to be creative after all. And appropriately, we return the response to based on conversation predict. So we can then look at how we can work with Amazon Poly to return a human-like voice. So Amazon Poly does quite a great job in being able to sound quite human. So I pretty much wanted to be able to replicate more or less a good, somewhat human-sounding voice. So that's what I tried to create from it. And as part of this, we're working with it to be able to first save it within SSML text. So if you're familiar with SSML, we're trying to save speech marks, essentially, to put it simply. So we're putting through the speech marks where we wanted to speak and how it will basically read the responses as well. So we're splitting the response text accordingly, and we're putting these marks as well as part of the SSML too. And then we initialize our Poly client to appropriately use the synthesized speech element function so that we can then output the format as MP3, save text appropriately, and appropriately have it voiced out as the voice ID, which is Ivy in this case scenario. And when we look to selecting an appropriate EC2 instance to stream, there's a couple of considerations, and you need to consider how compute intensive your workloads are too, because one of the things that you might be familiar with if you're already doing streaming as well, for example, or watching streamers, is that when you stream and play games at the same time, it actually takes a lot of compute. So it might not be as much if you stream alone. And by that, streaming itself already takes up a lot of compute. So that's something to take into consideration, especially if you're trying to pair it with gaming as well. So that's something to take into consideration. And there's a number of considerations that need to be taken into consideration. So a few of these include the need to balance cost and performance, which definitely is a consideration because you need to understand how much you're going to be consuming based on your workload, your compute. And as you can see before in my code, for example, that's why I'm also limiting the amount of tokens as well that I currently have too. So on the Bedrock side, I'm already trying to be a bit more cost efficient, but on the EC2 side, we also need to be as well. Aside from that, we also need to consider the instances within what family we need to use. So for example, in my case scenario, instances within the G4 family would be able to support NVIDIA-based workloads, which is what I would need. because I'm currently using streaming workloads. I'm currently also wanting to run gaming-related workloads as well. So we need a stream strong enough to do this. Using G4 AD, for example, having 8 gigabytes of CPU memory and AMD Radeon Pro V50 520 GPUs to support OBS streaming is something, frankly, that I've used before and I found pretty effective. And it's important to be able to interswitch between this and your local environment to see which one suits you better. Because as I mentioned, sometimes EC2 streaming might get it's a bit hard to manage sometimes. So I've already experimented as well, pretty much with switching between the EC2s and switching between the local streamings, and more or less just seeing what actually works best. So I've actually done a fair portion of local streaming as well, and it's actually pretty intensive for your computer too. So sometimes the voice actually starts to crackle a bit if you're not too careful because, well, the CPU is under a lot of workload, and that's what happens particularly if you're not supporting it with the right workloads. Next, we can look at how we can handle the storage of responses within DynamoDB. So there are a few considerations that we need to make in handling this. Firstly, we need to ensure that we're setting a retention period for the responses. So as you know, we want to be able to scale appropriately and also respond in the right way based on what users are providing to us. So we need to get rid of the responses that are maybe no longer relevant towards what we're currently talking about and really focus on the ones that really matter. That being said, we need to still take in the important pieces of conversation history to be able to then use at a later time too. So these kinds of history are very case-by-case based and might involve different things. For example, like your audience members' usernames, for example. If they've been a permanent member on your channel for a while, you might actually find it good to be able to then go back and actually have your AI streamer address them directly in a special way and acknowledge them for it. So these are just some examples of how to do that. Aside from that, we can also keep track of key user information, like as I mentioned before, so preferred names. And in general, you want to be able to refer to responses stored to be able to train the LLM further. Because as I mentioned, being able to train your streamer continuously and have it update based on the data you currently have already incurred is a very important thing to be able to ensure that the experience of your audience is optimal. And another big consideration is the optimization for peak usage as well. So there are a few strategies to deal with this. And one of them, as I imagine you would already know as well, could come from how EC2 loads are handled. So one way particularly to be able to support the EC2 loads and how they scale is by using EC2 autoscaling to support the loads. Aside from that, it's also important to understand that sometimes AI streamers may be under a lot of load. One of my experiences actually when I was doing a stream is that you actually get bombarded with a huge amount of messages. And sometimes, if you want to respond to all of them, it's very inefficient because basically, user will be already at message maybe 20 or something like that, and you'll still be responding to message 5. And next thing you know, your users start commenting like, why are you still here? Why are you responding to every single message? So what I found effective was to actually have the AI streamer then respond when their name is called or else skip to the last message. So this is a strategy that I concocted up to be able to deal with this particular problem. So the AI streamer's name that I have, for example, is Himena. So every time Himena is called, then she responds to it basically after a certain number of messages. So creating that particular strategy for dealing with these kinds of scenarios is a very important thing. Aside from that, it's also important to consider adjusting provisioned DynamoDB capacity as well, or using DynamoDB Accelerator, or DAX for short, for in-memory cache accordingly too. And how do you go about moderation strategies? Moderation is, I feel until now, one of each Twitch streamer's biggest challenges because, well, people will always try to do different things. And one of the biggest challenges that I faced as well when I was trying to put my AI streamer into the wild is when I started seeing people trying to make her hallucinate in a way, trying to get her to say things that would, well, get banned on Twitch, which is, I think, a lot of people, your audience members, you can never really control them. And one of the things that I started to then look at is how can I start efficiently limiting this while being able to still provide that freedom of speech that they want to be able to not make it too limiting. And so as part of this investigation, it came up with a few strategies too, which is using Automod, for example, which is a Twitch tool, or letting the LLM catch and flag it. So for my training data, I also use this kind of tool too to be able to then appropriately identify particular responses or words that might be banned that is good for moderating. Aside from that, yeah, appropriately have the AI learn as well. So now I'm going to be showing a bit of a demo on how this would actually look like in production.
Hey there, AWS reInvent 2023. I'm so glad to be able to be here and present my capabilities alongside Rinaldi. So without further ado, let's get right into the demo.
I'm doing great. Thanks for asking. I'm excited to chat more with you. What's new with you? That sounds fun. What kind of games have you been playing? I'm always looking for new ones to try out. Ooh, I love a good action game. What have you been playing lately? Handy Emissary 513. Do you want to play a game of notation chess with me? Let me know what difficulty you'd like to play on a scale of 1 to 8.
My move is D4E6. Open mouth smile. My move is D8 D5. Smile.
So that's a short capability demonstration of what she's capable of. So as you can see, in this case, I've also integrated a bit of a chess game. So how it works is that users just type in what move they want to make, and appropriately, she responds in the right way too. So she's able to accordingly do this over and over again until the game ends and commentate on the chessboard as well. So I did this by saving the context information of the board and put it into Bedrock too to be able to let her also commentate on what's currently going on too when asked about it. So it's a bit of a balance always, because sometimes your chat wants to also talk to Jimena as well, for example, in this case scenario, but at the same time, she still wants to also play with you as well properly. So it's a bit of a balance that you need to make, and it's really a bit of experimentation to really find out what works best for you. So as you can see, this is pretty much like part of the future of streaming. And speaking of the future of streaming, what can we expect to see in the future? So a few things, and I know that definitely on some of your heads as well, the first thing that comes in your mind as well is like, are there ethical considerations with this? Definitely. There's definitely going to be a lot of ethical considerations that are going to be part of this, but I foresee that in the future, it's definitely going to be efficient that streamers work along with AI as well to be able to perform streams appropriately too. And aside from that, you have a lot of potential for using this within a myriad of organizations. Having the power of 24/7 marketing, having her particularly just being able to be there, responding to different queries that your audience might have is a great thing. And aside from that, you also have AI-based content moderation. So I see that there's going to be much more development done within content moderation tools that will be taking place for these kinds of streams that will be needed. And there's going to be bigger need for personalization as well, which is something I'm investigating too. So being able to personalize your content, being able to personalize how you respond to user A, for example, who's been loyal to you for a while compared to user B, who might be just 3 days old in your channel, is a very important thing to make viewers feel more special that way. And aside from that, of course, there's going to be the potential for much more generative creativity. So that's all for me. Thank you so much for listening to my session. And if you want to connect with me, these are my socials. And I'll also be hanging around here too to answer any questions. So I'll be just outside as well in a few minutes. And please do complete the session survey in the mobile app too. Thank you.